we're about to see, did you do better on one than the other? And the answer, I think, is going to end up being a yes, but we're going to talk about how statistically you can compare two groups that have like a distinction between the two, but you're measuring the same thing. Like, I don't know how many points you earned on Kahoot. Is everybody good? So for your project, which I'm going to introduce to you guys tomorrow, which will be perfect because you'll have a long weekend to gather data if you want. For your project, I'm going to have you guys take all the stuff we've been learning. It's all incorporated in the project somehow. Tomorrow, I'm going to take you through me doing the project. So you guys, all you'll have to do is sit and listen. I'm going to record it. But it'll be me introducing the project and giving you a fully worked out example and explaining what I want you to do for each step. Is that good? I'll record it and post it on Schoology. So if you're not doing the project or you don't know how to do the project, and for instance, say I'm not here on one of your project work days, which is not unlikely, it's probably pretty likely that I won't be here Thursday afternoon, which is your last day to work on the project, you can consult a video that has me working through the project. Does this make sense? Yes. One of the things you're going to be asked to do is compare the data from two different groups. So what we're going to do real quick is compare the data between two different groups. Is this okay? So here's what I'd like you to do. If you were born in an odd birth month, that would be January, March, May, July, September, or November. Can you find me the 5-number summary of this first group?
Do you have a paper?
I just passed it out. Here. If you have an even birth month, that would be February, April, June, August, October, and December. Could you do the ancient world quiz instead?
Which one?
That's the worst.
Oh, I started doing oh, okay. Yeah.
Odds are doing the first group. Evens are doing the second group. Because odds have a 1, which is odd. Or something. Guys, how am I doing on these?
Fantastic.
Did anybody try to do these by hand instead of just typing them into the calculator?
No comment.
Was it fun to type these into the calculator?
No.
Did you notice that they were in decreasing order, so coming up and finding those midpoints would be pretty quick? No? I put these in decreasing order. And by I put these in decreasing order, I mean Kahoot put them in decreasing order. Because it shows me the rankings.
I guess I just didn't.
But this way I can still be sure if the answer and kind of that human error.
Fair enough. Okay. So I thought we would use this opportunity to kind of talk about outliers. Do you guys remember how to calculate outliers? Somewhat. Go ahead.
Isn't it Q3 minus Q1 gets the IQR?
The first thing we would do is Q3 minus Q1 and get our IQR. So for the first group, that is, something. 1539. Okay, so now that we know that IQR, so we're going to do, in this case, that would be 6534 minus 1.5 times 1539. Okay? And
That's 4225.
so do we have any low outliers?
No.
No. All right, then we're also going to do Q3 plus 1.5 times the IQR. So in this case, that would be 8,073 plus 8,593 times 1.5. Though I don't know what I just said there.
Yeah.
That was kind of crazy.
Confused for a second.
It's Gwen's fault.
Understandable.
She confuses me sometimes.
10,381.
So are we good with no outliers?
Agree with that.
Okay. Can you guys find the IQR of the blue group? $28.50? $27.50. $28.50.
What?
What is the IQR?
Oh. I got
$18.50?
I got 1849.9.
They're both ending in a 0.5.
Oh, that is a 5. Yeah, I got that number. I just wrote the 5.
So then we're going to do our IQR rule. What are we getting? Go ahead.
For the high, point, I got 7,553.5.
For the low one?
I got 153.
Probably 0.5.
Yes. I'll put the 0.5 in.
So, any outliers on this group? Okay, so we've done a basic summary analysis of each group, essentially. Can we compare these numbers?
Yeah.
Are you guys comfortable saying you did better on one than the other? And how would you justify that?
The average?
Did we calculate the average?
No.
Could it be that the outlier on the smaller end is higher?
I believe we just determined that there are no outliers. Yes?
Like the range?
Oh, so one of the things we like to do is once we can compare these actual numbers to each other, but what I'm going to do is create a new kind of graph that we haven't shown you guys yet, but it's very much related to an old graph. And that graph is going to essentially, what we're going to do is create something called a parallel box plot. Now, parallel means
Side by side?
side by side, yes? Never crossing. What we're going to do is draw two box plots on one axis, right above each other, okay, like next to each other. And when we do that, our goal is so that we can visually kind of compare what's going on. So I'm going to have an axis. I'm going to label it, have it go from 0 to 10,000, 0 to 9,000. And let's go ahead and start with the wonders of the world. Now, a reminder, a box plot is basically the 5-number summary. So the edge of my whisker is going to be 951, my minimum. So it's just going to be just short of 1,000. And that's okay if that's what it looks like, okay? It doesn't have to be absolutely perfect. All right, my Q1 is going to be 29 and 28.5, so a little bit short of 3,000. My median, a little bit more than halfway from 4,000 to 5,000. And notice I labeled which box that was. Which section is the most densely packed? I don't know if that makes sense. Yeah.
Between the median and Q.
The median in Q3. So as we're thinking through, guys, we have a lot of as many points in this little box as we do in this one. And that's worth noting. Okay? All right. Then we're just going to do the red graph up above. So this was gorillas, right?
Yeah.
So the min is 5,600. 6534. 7,600. Just 1,000. Yeah.
What is the box? In between the min and max, the box.
The quartiles, the other three numbers of the 5-number summary, these ones. So this 6534, be right about there. Just past halfway between 6,000 and 7,000. And guys, when you look at these, now comparing the red graph to the blue graph, are you comfortable saying that you did way better on the gorillas quiz, even though it had less questions on it than the 7 wonders quiz? Okay. And what about this graph tells you that?
The box, like the Q1 and to Q3 is ahead of like even the whisker.
Okay. And in fact, if we were to like compare this point to this point, it's so the lowest is the way lowest, way lower on the ancient world graph, right? Okay? And likewise, if I compare this value to this value, like when we think about that 5-number summary, each is a different measurement of our data set. Every single measurement on the blue graph is lower. It's more to the left than every measurement on the red graph. Is everybody good? So we can definitely say you did better on one quiz than the other. Is this okay? Do you guys see anything else that kind of jumps out at you besides the fact that the red graph is so much further to the right?
It's also a lot smaller.
What do you mean by smaller?
The points are more tightly compact rather than.
Okay, there's a lot less variability. Like you guys all knew it's way more predictable how you would have scored on that gorilla quiz than it was on the ancient world quiz. Yeah.
The median to Q3 area is also a lot farther up, showing like, and also it's bigger, showing the majority of people just did better overall, or like over half, I guess.
Ish, yeah. Yeah. Theoretically, we could see a little bit of overlap here. Okay? Now, what if I asked you guys to make a parallel dot plot?
Look like a bunch of dots.
It won't, because we're actually going to do it in 2 different layers, but still one axis. So, notice I'm putting labels on the axes still. Are we still working on just getting the graph drawn? Okay, so your project's going to include that parallel box plot. It's not going to include the parallel dot plot, but it is worth noting that they're easier to make some comparisons. Now, what are some things we might be able to see in the dot plot that we can't necessarily see in the box plot? Exactly where people scored, but there's some other things I kind of think I see here.
You can see overlap.
We can see that there is a little bit of overlap, which we theoretically... You know what else I see that I think is kind of interesting? It's almost like there's like clusters of points. Does that make sense considering what this context was?
Yeah,
Why?
because there's a certain number of answers, so it kind of shows if somebody got like 7 out of 10, like those people.
Yeah, like it's certainly like there was no people who got 6.5 right. So the only variability between say 6,000 and 7,000 is the speed with which you answered the question. For sure. I might say, and we haven't talked about this super formally, but you guys can see how for at least that Seven Wonders graph, most people were like right here. But then there's kind of like a huge tail on the left of it. Do you guys kind of see that? Okay, so that means the low scores for that group were a lot lower comparatively to the gorillas quiz. Okay, now, 2 things happened that day. Number 1, I picked one quiz, you guys picked the other. And 2, the second quiz where you guys weren't getting things right. Some people zoned out, only answered some of the questions. Does that make sense? So to me, it makes sense to see this in the graph. That's a story that's part of the story being told by looking at these graphs together. Okay? All right, now, if, and when I say if, I mean when on your project, I ask you to write a few sentences comparing the 2 different groups. Our whole goal of the project is going to be that you look at the graphs and the summary statistics of 2 different groups, like, I don't know, a group of answers to the gorilla quiz versus a group of answers to the other one, okay? And make some statements about the differences amongst those groups, okay? So when I look at these graphs and what do they tell me, whether it be the box plot or this one, there's 2 things I want you to kind of compare, the center and the spread. Okay, so are we comfortable saying that the median, I can spell median, score for the gorillas is higher? Than for the 7 ancient wonders? That's true, right? And the median is a measure of center, so it'd be completely appropriate. It'd be appropriate for me to talk about the mean. I'm actually comfortable saying that the average, the mean for that red graph is probably higher than the average for the blue graph, even though we haven't calculated it. On your project, you will calculate it, and you can reference that as well, okay? Which graph is more spread out?
Wonders.
The wonders, okay? Okay, so the ancient wonders graph has more variability. And scores were less predictable. That's what that really boils down to. Why we care about that variability. How are we feeling about this? Good? All right. If you did not turn in your graded assignment yesterday, you should finish working on that right now. If not, you can just use this as like a study time.